A very warm good afternoon to respected professors, scientists, and all the participants present here. It's my pleasure to welcome you all to the 27th technical talk series entitled Transtech Talk Series, organized by KSCST National Transportation Planning and Center, NATPAC. Through this technical talk, we aim to provide a platform for the experts in the field of transportation to share their knowledge and expertise with us. These sessions offer insights into the latest developments, emerging trends, and cutting-edge technologies in this field. I would like to express my gratitude to all of you for joining us today. We are delighted to have distinguished Dr. Joseph Praful Tomy as our speaker today. He will be sharing his valuable insights with us on the topic underwater radiated noise due to maritime transportation. Before we begin, I would like to invite Sarah Nember, scientist, Water Transportation Division, including GIS, NATPAC, to deliver the welcome address. Over to you, sir.
Thank you, Chitra. So, good afternoon, everyone. KSCST-NATPAC proudly presents the Transtech Talk Series, a platform designed to explore the key areas in transportation research by engaging global experts in sharing their research findings, innovative approaches, and professional experiences. The inaugural session of the series was held on 10th February 2023 through an online platform with the participation of over 200 attendees from eminent institutions and departments. The inaugural address was delivered by Professor Tomy Matthew, Chairman of the Research Council at the institution and the professor at IIT Bombay. The first talk was presented by Dr. Srinivas S. Gupta, Professor and Research Director at the Department of Civil and Environmental Engineering, the University of North Carolina at Charlotte, on topic Advancing Crash Frequency Prediction Modeling using GIS. To date, we have successfully conducted 26 lectures covering a wide range of topics within the field of traffic and transportation. Today, we are delighted to host the 27th talk in the series. It is with great pleasure and enthusiasm that I extend a warm welcome to Dr. Joseph Praful Tomy, Hydrodynamic Research Engineer at MAN Engineering Solution, Copenhagen, Denmark. Dr. Tomy has graciously accepted our invitation to deliver a talk on underwater radiated noise due to maritime transportation. A heartfelt welcome to Dr. Tomy. Following the presentation, we will have a question and answer session where you can interact with Dr. Tomy, ask questions and engage in insightful discussions. Feel free to unmute yourself to ask the questions or share them in the chat box. Thank you all for being here today. Let us look forward to an informative and interactive session. Thank you.
I would like to invite Srimati Veena KS, scientist, NATPAC, to introduce our esteemed speaker.
Dr. Joseph Praful Tomy is a hydrodynamics research engineer in the Propeller Design Department at MAN Energy Solutions, Copenhagen, Denmark. Dr. Joseph earned his PhD from the Technical University of Denmark and completed a dual master degree in advanced ship design. He has experience working with various facets in the maritime industry, ship design and building at Goa Shipyard Limited, marine composite structures and rule development at Bureau Veritas, and marine propeller design and hydrodynamics at MAN Energy Solutions. Over to you, sir.
Yeah, thank you so much for this introduction, and welcome everyone to this talk. It's great to have this opportunity to present something about my work and to the National Transportation Committee. And I hope you get some information out of this which would be useful in your research and your future work. So let me share the screen without further delay. Okay, just a second. Yes, please let me know if you can see the screen.
Yes, it is visible. Please continue.
Yes. Yeah. Okay. Thanks. So the topic for my presentation today, it is underwater radiated noise due to maritime transport. So from what I understand, it's so the audience here are not specialized in maritime transport per se. So and probably underwater noise is something which many of you are may have heard about, but not familiarized yourself in detail. So the purpose of today's talk is just to give an overview of what this problem of underwater noise is, and how is this caused as a part of shipping transport in general. So this is a small slide about me. I think that this was already introduced. But I just want to touch upon a few points. So I am an alumnus of the Cochin University of Science and Technology. I graduated in 2013. And thereafter, I've been working in a few companies. So firstly at Goa, in Goa shipyard, and then I was in France for a couple of years, and currently I'm working in Denmark, wherein recently I have completed my PhD on the topic underwater radiated noise prediction for marine propellers. This is kind of my specialization at the moment, and so that's why it's of great pleasure that I can introduce this topic to this audience. And so since I'm aware that most of you are not so well versed in the shipping industry as a whole, so that's why I would like to start off with a few details on maritime transport. And maybe this is familiar to some of you, but it's just a rough introduction about before going into the problem of underwater noise. So to say about what kind of ships are traversing our oceans, and before understanding the problem, we need to kind of look at what is the scenario in which this problem of underwater noise is being created. So if you look at the different types of ships, so we have cargo ships that are the most common in the oceans. So these are probably carrying cargo from one country or one continent to another continent across large distances. But there are different kinds of ships being built. On the left top corner, so you have these container ships. So these are quite distinguishable if they have cargo on board. So you have these stacks of containers on the deck, and then that makes it easy to recognize a container ship that is coming to the port or leaving the port. And in addition, so there are these bulk cargo carriers. So these are ships which carry bulk cargo like grain or minerals and things like that. So which are like stored in these what we call as holds so the entire hull of the ship is filled with this kind of bulk cargo. And then these tanker ships, so these are usually carrying liquid cargo like petroleum or other chemicals. They are easily distinguishable by these. If you see the deck here, so that's the green deck here, which is quite flat and clear, and you have a lot of piping on board because there are a lot of chemicals inside the ship. So these are called tanker ships. And similar to the tankers, but instead of carrying liquid cargo, so what carries gas cargo are called gas carriers. So these can be like LNG or LPG carriers, which carry from places where they are abundant to consumer countries. And when you see tanks like this, so these are typical of gas carrier ships. And then here in the bottom middle, you have general cargo ships. So these are ships which carry cargo, so if you look at all the other four types, they carry specific type of cargo. So general cargo ships are ships which carry general type of cargo. It could be containers, it could be small packages, it could be large amount of export material and things like that. And usually they are characterized by they have these small cranes on board the ship to load and unload the cargo once they reach the port. Then on the bottom left corner, you have car carriers, which are typically ships which carry automotive vehicles like cars and trucks from their manufacturing country to the destination country. So usually you have a lot of these ships traveling from Far East, so like Korea, Japan, to other countries where you have a lot of consumption of these automotives. And so that's just to give an overview of different types of ships that are traveling through our oceans. And probably next time when you see a ship on the port, seeing this, you can have an idea of what kind of ship it is and what kind of cargo it is carrying. And so that's one part of the maritime transport, which is cargo ships. And then you have also passenger ships. So these are the large cruise liners, which are typical for pleasure trips, and they also travel like over a long distance, say across the Atlantic, and so they have a very luxurious accommodation, and usually are the largest ships in the world in terms of size. And you have accommodation on board for over 6,000 people in some cases, and these are luxury vessels. And then also you have these kind of RoPax ferries, what we call them. So RoPax is row is for like roll-on, roll-off. So that's like these ships can transport cars and trucks, so wheeled vehicles on board. So it's basically something like a jangar, but a much more larger one, which can carry people across islands or from mainland to the island, and also passengers. So that so it carries basically it's like a jangar, but for larger distances. And the image here, it's for a RoPax ferry off the coast from Mumbai to Alibag, I imagine. So that's quite a big ship, and it carries both cars and people on board. And so in the shipping world, what these cargo and passenger ships together, these are what we characterize as commercial ships, because they take part, they are money-making ships in a sense, because they carry cargo and passengers from one shore to another, in a sense. So what ships other than commercial are mainly the military ships. So these are basically ships from the different navies, and this also take a huge role in the ocean, and eventually to the underwater noise, and so anything related to the shipping related emissions. Both the commercial ships and military ships contribute, but in different ways, and we will look at that in detail in the coming slides. But these are some of the typical military ships that you can see: submarines, frigates, aircraft carriers, or landing platform docks. These are some examples of military ships that are being built nowadays. And then coming to the environmental impacts of shipping. So we know that there are a lot of ships in the ocean. Some of them carry cargo, some of them carry passengers, some are military vessels intended for the defense of a nation. But as similar to the problems in road transportation, you have similar problems in water also, but at a larger scale. So we have emissions, air emissions. So these are emissions of sulfur oxides or nitrous oxides, which contribute to the climate change, and and carbon emissions, which can affect the greenhouse gases. And in addition, you have discharges to water, which can be in the form of wastewater, or they can be oil spillages, which are detrimental to the life underwater. And there are also physical impacts like collision between ships, collision of a ship to the port. So similar problems to what you see with road transportation, but I would say these are at a much larger scales, because the ships which travel in the ocean, they are much bigger, so the engines are much bigger, so the emissions are much larger. So there is always a greater concern about the environmental impacts of shipping. And I suppose I've heard that you already had a talk related to the marine decarbonization, which is basically air emissions from the ship. But today we are going to focus on one of these points, which is the noise radiated underwater from ships. And so that's the underwater radiated noise. That's the problem which we are going to focus on today. So before I start about underwater noise, I want to put a framework on why it is important, and from the perspective of the United Nations. So on the left side picture here, you have the Sustainable Development Goals, 17 SDGs that are proposed by the United Nations. And among this, we have all heard about, or there's a lot of talk about climate action, which is one of the points. But equally important is point 14, which is SDG 14, which is life below water. So that's one of the, along with climate action, it is, so if you look at this right side figure, so this is how these SDGs are classified in different levels. So at the base of all UN action, there is this, and then the focus of improvement is that of the biosphere. And along with the climate action, which is number 13, life below water is also one of the critical points that the United Nations is working to improve. So that is why problems such as underwater noise, even though they are less talked about right now, but they are gaining more and more importance, because it is essentially something that is that will greatly affect the biodiversity of the planet in the same intensity as that of say greenhouse gas emissions. So it is definitely important to consider this in most of our research work, and that is why this topic is gaining more and more importance nowadays. And with that, I will start with the topic of underwater radiated noise. So what it is and how shipping contributes to this. So I'll start with a video of how these, so why underwater noise is important to marine animals. So this is in terms of, so pretty typically for marine mammals such as whales, which use noise as a communication mechanism. So just play this. So, Could somebody tell me if you could hear the audio from the video, or
No.
no, you cannot hear? Okay. Yeah, sorry about that. I think it's something with the IT setup, but okay. I'll just explain then. It's basically animals such as the whales, they use noise as a means of communication. Sorry. So because these creatures, their primary sense of communication is through sound. So when they have to talk or communicate with other whales, so what they use is noise signals, and then the response is also through noise signals. And with ships in the ocean which also emit noise, and then it's this interferes with their communication channel, and that makes it very difficult for such animals to communicate. So if you look at this infographic here, so you can see animals such as the whales and dolphins, they use noise as or sound to communicate with each other. And when you have ships passing nearby, they generate also noise, which is very difficult then for them to talk to each other. So like you can imagine, if you are talking to your friend, and suddenly there is a lot of traffic in the road, and then so you have to be heard or to understand to make the other person understand what you're trying to speak. And it is a very similar situation in the ocean, but it is much more critical because unlike air, the sound travels much faster and longer in the ocean. So that makes it even more, the disturbance from the ships make it even more difficult for these animals to communicate with each other. So this can be due to ships passing by, or then you can have seismic surveys. So these are like again signals sent or noise sound signals sent underwater to check for earthquakes underwater, and other to measure the depth of the ocean, and other things like echo sounders. Or even during the development of wind farms, you have these kind of sound signals sent underwater, which detrimentally affect the aquatic life in that region. And what this causes is from the perspective of the marine animal. So it can, in critical cases, it can even lead to hearing impairment. And so that is a very critical issue in terms of marine animals, because their major means of communication is underwater is through sound, and because the visibility is very poor in deep oceans. So without hearing, then the animal cannot survive for much longer. And when you have communication troubles, it can also mainly lead to difficulties in breeding between these animals. So that is definitely affecting the population of many of these animals like whales and dolphins in the ocean, because they cannot communicate with each other. And it can also behavior which can lead to whale attacks or on ships and things like that. So these are some of the impact of underwater noise on marine species, and typically these are caused through ships passing by, and mainly from the machinery of the ship, as well as the ship propeller, which is a major source of underwater noise related to shipping. And that's again showing what are the sources of shipping noise, isolating a ship. So what all contribute to the shipping noise? So the main culprit, or the main cause, is the propeller rotating underwater, and that creates a lot of noise due to its rotation as well as cavitation. I'll come back to that point later. And then the machinery on board, which are these large engines, and they also generate some noise which is transmitted through the hull of the ship underwater. Then the major issue here is that in water the sound travels much faster and much over large distances and compared to air. So because there are much lesser obstacles also under in the ocean. And then even though the generated noise is lower, but since it travels much further away, so this can be very detrimental to the survival of many species. And you might think it's maybe a few species, but that's not the case. There are many aquatic species which use sound as a means of communication, and adversely affecting some of these species can change the very detrimental to the planet as a whole. And this is a video showing how propellers generate noise. So when propellers rotate underwater, so you have this phenomenon known as cavitation. So this is essentially the formation of these air bubbles inside the water because of the low pressure in which they are working in. Essentially, what you can think of cavitation as it's the same as boiling of water. So when you boil water at 100 degrees Celsius, you get a lot of these bubbles. But again, this change in state of water to water vapor can be, in case of boiling, it is brought about by an increase in temperature. And the same thing can be brought about by a reduction in pressure, and that is what is causing these bubbles around the propeller. So when the propeller rotates, it generates a region of very low pressure, and then a phenomenon very similar to boiling, where the water is transformed into water vapor, and these water vapors are then changing in its shape as well as colliding in the vicinity, and these generate a lot of noise, which are so even with boiling of water you can hear that it's a bit noisy, but underwater it's even more noisier, this phenomenon of cavitation. And that is one of the major causes of shipping noise, these cavitation bubbles forming and imploding on the propeller surface. And then there is also one point I want to make, that is distinguishing between onboard noise and radiated noise. So because sometimes for people who have traveled on ships, they say the ship is very noisy. So that's what you feel when you are on the ship. So that's the onboard noise. And so the difference here is that, so let's look at the right side figure. So that's the case of an engine. So engine installed on the ship, and onboard noise is what you feel, say the airborne noise in the if you're standing somewhere here. So it's the then you feel it or you hear it. So that's the airborne noise and structure-borne noise that you hear on board. But radiated noise is what noise you feel or hear when you are outside in the ocean, so out of the ship. So so that is essentially, so if you look at the propeller, so the propeller generates some noise, and this noise is radiated into the ocean, which is directly felt by any being in any species in the ocean. And this also contributes to the onboard noise, but the radiated noise is much more critical when it comes to the propeller. And it's also the other way, the structure-borne noise can also be radiated radiated to the sea through vibrations of the ship structure or the ship hull. And this is also one of the contributing factors to noise. But chiefly, it is what is contributing to the radiated noise is the propeller pressure pulses, which are radiated into the ocean. Yes, so that was a short introduction to underwater noise, I would say. Nothing too technical in this, but if we want to have a technical discussion, we can have that in the Q&A session. So I don't have anything further on the technical aspects of underwater noise yet, but we will go to some of the mitigation policies. So what is being done currently to address this issue of underwater noise, and how successful are we, or what more can be done? So in the general approaches against URN, against underwater noise, is so they can be classified as three different class of actions. So the first one is what you call as vessel slowdown. So that is quite an obvious solution. So if the so similar to in the road, if you have noise and you want the I'm talking only about the noise due to the vehicles passing by, and this can be reduced if the vehicles pass at a slower speed, and that is very similar also in the ocean. So this is depicted by this concept known as the swath. So if you see here, for a vessel moving at a larger speed, which has a higher source level, so the footprint is much larger as compared to a vessel which is going at a slower speed. So this is a simple to implement solution, but of course it has other financial and implications, because if you want vessels to slow down, then would that mean increasing the number of vessels in the ocean, and how slow is slowing down, and all these issues, and so that would also impact cargo delivery, and then would that mean that you will have a shift of cargo delivery from the sea to the to air freight, so that is even more environmentally harmful. So these kind of questions are definitely associated with this simple solution of vessel slowdown, and so that brings to the most robust of the approaches, which is technological modification. So that is where most of the research now is related to underwater noise. So how can we understand the phenomenon of noise much more, and how can we design ships that are more silent? So that can be in terms of propellers which are more silent, ship hull forms or ship shapes which are much more silent compared to existing ones. Because right now, or even in the past, until say 2010 or something, most of the ship design, propeller design, has only been focused on optimizing the efficiency of the ship. So underwater noise based designs were never a concern, because that was never a problem that was dealt with by the designers. But now there is an increased focus on having ship designs which are more compatible or more environmental friendly, both in terms of carbon emissions as well as in terms of noise emissions underwater. It's a large bucket of solutions, and there is no single solution yet related to technological modification. But there's a lot of research going on in this aspect to reduce underwater noise. And then there is a policy-related solution, which is separating vessels, separating ships from the animals which are being affected. So that's mainly in relation to modifying the ship routes such that you have protected zones similar to how we have this kind of protected rainforest area or protected forest areas. Similar to that, you have ocean areas where there are protected species, and shipping traffic is diverted from those zones in the ocean. And so that's like that requires a large-scale policy implementation in the oceans to separate shipping traffic from the animals that are being affected by this traffic. So these are just general classifications of approaches against mitigating underwater noise in the oceans. The specifics can be discussed further if needed. But in terms of rules and guidelines, so you have multi-level governance in the maritime world related to not just underwater noise, but related to any kind of environmental impact. So at the top you have the International Maritime Organization, which is the body which distributes or prescribes rules and regulations for the entire world. And then you have classification societies in the shipping world, which are which check and carry out regular inspections and surveys to ensure that these rules are implemented. I'll come back to these points in the coming slides. And at the bottom level, but these are just bodies which prescribe rules, but eventually to have these rules incentivized, you have to have local authorities like the ports to give some incentive to the ship owner or the customer to have some incentive to implement these rules, just like decarbonization rules. So that's what we will come to in the following slides. So firstly, the IMO, the International Maritime Organization, it is a specialized agency of the United Nations. With the main responsibility can be categorized as safety and security of shipping, as well as the prevention of pollution. So that can be any kind of pollution. So it can be air pollution, atmospheric pollution, emission of greenhouse gases, and also water pollution, which is also a major side effect of maritime transport. So here, the underwater noise, it comes as a part of water pollution, or it's a combination of water as well as noise pollution. And that's why the IMO has some guidelines for reduction of URN from shipping. So you can see it's only adopted as late as April 2014, whereas the atmospheric pollution was had been in discussion even much earlier. But this is a relatively new rule, and again, it's not a rule; it's still a guideline. So it is not imposed on all ships. It's still a guideline for commercial ship owners, because there is resistance, of course, from ship owners to implement such a thing, because you are changing the way that you are working for a long time. So it's the rules are still under discussion. As of now, it is just guidelines for reduction of underwater noise from commercial shipping. And these reduction approaches, IMO, they classify into 3 different categories. So it can be either design and technical changes. So this is what I talked about earlier in terms of modifying the propeller design or modifying the design to have ships that generate less noise. But then you can also have maintenance-based approaches, which is like, so you have to maintain the ship in such a state that over the course of time it does not create noise further. So it's you can probably correlated to some of the machines you have at home. Over time, it gets more noisy, and if you don't maintain it well. And it's the same thing which is applicable to ships. So you need to have a maintenance plan such that it does not create more noise as it continues its service. And then there are operational related reduction approaches, like reducing speed at certain zones where you know that there are animals which are possibly being affected, and other operational things like changing the shipping route and things like that. So these are just, again, guidelines for ship owners and shipbuilders to reduce URN, but the rules are still under discussion, and hopefully they come into place sometime soon. But again, one more thing is the incentivization. This is not the responsibility of the IMO. So the IMO only is responsible for coming up with rules, but in order to have these rules properly implemented, you have to have some incentive for the ship owners, whether it's in terms of cost, or it could be in terms of some regulatory fines or something. Until then, it is very difficult to have ship owners implement these rules. And these incentivization, it is again carried on to the maritime, so local maritime authorities, like say, so if you have speak about Kochi, so if you have say the Cochin Port Trust implementing some rules saying that only ships below a certain noise level is allowed to enter our port, and that is then an incentive for ship owners to reduce the noise of their vessels. Or you can have like insurance authorities which say only if your ship has so and so levels of noise, that we give you a insurance discount or something like that. So unless there is some kind of such incentives, it is still difficult to implement this kind of rules in the shipping world. But yeah, I think it would eventually come, because it was the same situation with decarbonization. When it started, there was a lot of resistance, but eventually the rules were in place, and now there is a lot of incentives for ship owners to reduce their carbon emissions. So underwater noise also probably will be going in such a path. And for regarding to classification societies, so these are not governmental bodies, but non-governmental organizations that establish and maintain certain technical standards. So similar to the ISO, but standards specific to ships and shipbuilding and anything related to the ocean. So they carry out regular surveys and inspections on board ships to ensure that ships and processes, shipbuilding processes, are compliant to these technical standards. Some examples are this American Bureau of Shipping. Then in India, we have the Indian Register of Shipping, which is responsible for which generates technical standards for ships being built in India. So many of these, almost all major classification societies now have guidelines again, or technical standards for silent class ships. So that's the silent class notation, what we call, which is available for all major classification societies. And so that's definitely one of the steps forward, or a path where the ship owners can again choose. So it's again an optional class notation, which commercial ship owners, they can choose to have to improve the noise characteristics of their ships. And then some examples of local port authority implementing such kind of incentives for ship owners. So this is an example from Port of Vancouver in Canada. So that's somewhere here. So in this catchment area of the Port of Vancouver, so there are like it is a well-known habitat for many whales, And so they have introduced a system where you have these slow down areas, and so they have first of all restricted ships below a certain level of noise from entering the your ship has to have below a certain level of noise before entering the port of Vancouver, and they have if that does not comply, then you have to slow down in these slow down areas which are again sensitive in terms of marine aquatics, and so you if you have the low noise characteristic, then you are given some financial incentive or a discount with related in relation to the port charges. So that's something. Then it's an incentive for ship owners to build ships which are less noisier, to have this kind of certification, and then they get a financial discount which is which can then improve the overall noise radiated in the ocean. So that's one example, and there are other areas where this kind of noise is of prominence around the world. So these are some of the areas, like in the Europe you have the North Sea and Baltic Sea, which are important for some other species. So in the Salish Sea, close to Vancouver, so that's specific for whales. And then you have the Great Barrier Reef, and in Chile you have this Corocod Gulf. So these are all noise sensitive areas, so where the local port authorities are again looking into rules, implementation of rules to incentivize ship owners. And there's one thing about, so I started with the different types of ships, this commercial and military ships. So what needs to be understood here is that in terms of military ships, the reducing the underwater noise has been a focus for much longer time as in relation to commercial vessels. So that is to say, most of the heavy military ships, they have a very reduced noise signature, but this is not due to a concern with the marine life. So it is mainly because the noise signature is related to the stealth of the ship. So if you don't want an enemy submarine to detect your ship, you have to have a military ship. You have to have a very low noise radiated in the ocean. So because of this, in military shipbuilding, the low noise has always been a concern since past 50, 60 years, because this is what submarines usually use to identify and target enemy ships. But now, but the interest from commercial vessels have been very limited, and the focus now of IMO and all maritime authorities is to increase the interest and incentive for reduced noise from commercial vessels. So that was the cargo ships and passenger ships and other commercial vessels operating in the ocean. And the new rules, they are developed mainly to these kind of vessels. But of course, we are using some of the learnings from military stealth design being applied to commercial ships. This may not always be the case, because the nature of ship operations can be very different between commercial ships and military ships. But it's a process. It's a process in operation. So as we know more about, as we get more requirements for reduced noise requirements from commercial ships, this process gets improved. But this is just a note to distinguish between the different types of ships and how they deal with underwater noise. So just to conclude, so why are these URN policies difficult? I'm not going to these noise characteristics. It is difficult to specify them as a single value. Like say, in terms of carbon emissions, you can say certain parts per million of CO2 being emitted. So that it's very difficult in the same to say in the same stretch related to noise, because usually the noise is characterized as a noise spectrum across different frequencies, and depending on what target species you are targeting to protect, you can have different frequency ranges where the noise is more important. So this is a technical challenge in terms of implementing policies, and then there is a problem of incentivizing ship owners to have a reduced noise signature. And in relation to vessel slowdown, as I said, it's an easy solution, but the financial impacts of it are difficult to ascertain at the moment, because if it leads to an increase in air traffic, for example, then that does not solve the larger problem. So that these are still things under discussion and at a larger stage. And there are a lot of research projects going on at the moment in relation to understanding noise and measuring noise and reducing noise. So these are some examples related to noise-related research projects ongoing or which have been completed. So just to show you that there is still a lot of work to be done, and there's a lot of work being done related to noise. Yes, that's all I had for today. But yeah, now we can questions, please.
Thank you, Dr. Tomy, for this wonderful presentation. Now the floor is open for discussion. You can unmute yourself and ask questions, or else you can just type in the chat box as well.
First of all, thank you for a very informative presentation. And myself, Dr. Anisha, I'm working as a scientist B in Water Transport Division. And today we have discussed different approaches for reducing underwater noise, such as slowing down the vessel, or technological adoption, or separating the vessel-animal boundary. So in that technological adoption, which is more effective, in your opinion, which is more effective for reducing underwater noise, which is mainly commonly adopted by industry without compromising the propeller efficiency or functionality of the hull or any other appendages. So,
yeah, thanks, Rabisha, for this interesting question. Yes, it's definitely one of the major focuses of my work and my colleagues to have this kind of technological improvements to reduce noise. And mainly, like I said, the main culprit usually is the propeller. So that's why improving the propeller design is definitely what the focus is on right now in relation to reducing noise. And like I said, it's definitely has an impact on the efficiency. So it's usually not the case that you can improve efficiency as well as improve noise behavior. So usually there is a compromise. So as a designer as a propeller designer, what you have to look into is at the design stage, if you have a requirement of reduced noise from the customer, then even if it's at the compromise of certain efficiency, you can still make it work. But once the ship is built and once the propeller is in place, then it is always difficult to reduce the noise, because then the only option is to slow down the ship, or so that even that, if you slow down the ship, then you are operating at a less optimal condition, and that increases fuel consumption and fuel emissions or carbon emissions. So that has always this problem. So that's why it's important as an owner to decide at the initial design stage that yes, I want a propeller which is or I want a ship which is less noisy, and then at the design stage, if you can incorporate these changes, then that would be the best.
okay, thank you. Then how it can be incorporated in military vessels? From long-term words.
Yeah.
Military vessels.
Yeah. So Yes, for military vessels, it's the design concept is completely different because so usually in terms of budget, the military vessels are much more they are much less restricted in terms of the budget of research and of design time, as well as you have to do a lot of testing for this. So that's why it's for military vessels, it's normally one of the critical requirements. So they even at the cost of efficiency, the noise signature is much more important than efficiency for a military vessel in terms of propeller design. But for commercial vessels, this is not the case right now because more efficient propeller is what the customer usually requires, because that would ensure that the transport times are lesser and you can get cargo from one place to another in much efficiently. And so noise is less of a concern for commercial ships. So if, as it stands now, for a commercial ship to have a reduced noise signature, it would increase the cost because you need more testing, of course, more design time as well as more testing. But as we have more and more requirements, then this is definitely going to come down. And that's not, I mean, it will take a few years at least to reach that stage. So yeah, that's how it is now.
Okay. Thank you.
Yeah.
Dr. Tomy, I have a doubt. Like you are suggesting 3 measures in which this pollution, like noise, can be reduced. The first is a swath, and second is, as you have mentioned now, technological innovations, and finally that removing the animals or those things from this like conflict zone, like can move it.
Yes.
Like how far like this implementation, apart from the second one, that is the technical innovations, are there like implementation of the first and the third measures anywhere, like it is find useful or like because
yeah, so with relation to the first one, so the vessel slowdown one, so the example which I showed told in Vancouver, so that's in Port of Vancouver with the vessel slowdown. So there has been been an increase, or it has improved the life of whales in the region. So that is definitely one of the positive signs. But again, it takes some time for you to evaluate these kind of things, because so say you slow down for 1 year, and how long do you have to wait to see the impact, because this you are talking in terms of generations of species. So assessing the impact is also one of the problems. But in terms of Vancouver, they have definitely reported some improvements related to the whale population there. And then the last one was about this separating of vessels and mammals. So vessels and species. So this, again, as far as I know, there has been a proposal, at least in the Baltic Sea, to modify ship routes to avoid critically sensitive zones, to avoid critically sensitive zones. But I'm not sure if it has been implemented. But in any case, it's too early to judge it yet. So it's been at least only 1 year since the proposal has been in place. So we will still need to wait a few years to know whether or to understand how much of an impact this has. So yeah.
Okay, that's great. But like we have seasonal migrations, like in the land, these whales and other things will be migrating from one area to another. So that will be also taken into consideration, because they're not like static; they are on the move. So that will also have
exactly.
impact on. But that means that.
Yeah, this I'm I'm not a marine biologist, so I don't know the details, but I'm sure like the people who identify zones, they would consider this kind of migrational patterns. So yeah, I think that's how they identify these zones, special zones for some of the animals. Yeah.
Okay, thank you.
Yeah. So it's usually these kind of where especially the breeding zones, that's what they characterize as sensitive zones, because in relation to breeding, so that's when this noise is definitely detrimental for communication between these animals. So that I think is one of the critical things to consider here.
Okay.
There's a question in the chat box.
Yes. Let me see.
Yeah, how pile driving and other offshore construction affect our costs?
Yeah, that's a very interesting question there. So pile driving is again so these are like very heavy shock noises which definitely scare away any animals in the region. So it's you can imagine the same like in land. So when you have a pile driving, that area is very noisy and you don't want to go near that. So it is as opposed to like vessel traffic or normal traffic noise, which is like a continuous noise. So this is like impact noise, but of very high intensity. So any animal cannot stay in the vicinity for a long time, and it has even there have been sightings of whales coming ashore due to some of this pile driving underwater. But what is normally being done in this case is, so normally you don't just start pile driving with a full force from the start. So normally you have to, there are some procedures in place where you have to like start slowly and so kind of give a warning to any animals around before you start driving at pile driving at full intensity. And so that's one of the ways to avoid this. And nowadays you also have these mitigation measures, which are, so you have what is called bubble curtains around this pile driving area, which kind of absorbs some of the noise or most of the noise within that area, so that what is radiated outside is much lesser. But of course, this is very harmful effect to any animal nearby. It can cause even permanent damage to the hearing.
Thank you, sir. That was an enlightening
Yes.
talk. Now,
Yeah.
I would like to invite Dr. Ramesh TV, Junior Scientist NATPAC, to deliver the vote of thanks.
Good afternoon, everyone. It's indeed a great honor and privilege for me to deliver the vote of thanks for today's enlightening technical talk on the underwater radiated noise due to maritime transportation. First and foremost, I would like to extend our heartfelt gratitude to Dr. Praful Tomy for sharing his deep expertise with us. Your engaging talk has greatly enhanced our understanding of this critical and emerging environmental concern, especially in the context of rapid growth of global maritime transportation. A special thanks to our director, Professor Dr. K.P. Sudhir, for his constant guidance and support, without which this event would not have been taken the wonderful shape it did. I would also like to sincerely thank all the participants for your active engagement throughout the session. Finally, a big thanks to the entire NATPAC team for the efforts behind the scenes in planning and organizing this session so smoothly. As we conclude, let us carry forward the insights we have gained today and let them inspire us towards greater research, innovation, and excellence in the field of maritime transportation and environmental sustainability. Once again, thank you all for making this event a resounding success. We look forward to hosting more such enlightening sessions in the future. Thank you and have a wonderful day.
Yeah, thank you, Ramesh. Yeah, thank you everyone for attending this talk. Yes. If you have any further questions, yeah, please write to me or something. Yes.
Thank you, and we
Thank
can
you.
wind up. Thank you.